All right, on page 186, I have us that, let's see, we're ready to do 8, problem 8. It says determine the value of the parameters S for which the system has unique solution and describe the solutions. So what we have is 3 is 8. 3 SX1 plus 5x2 equals 3. 12x1 plus 5sx2 equals 2. And the best thing to do with this is write it in AX plus B. AX equal B. So that the A is 3s 5, 12, and 5s. And the x is x1, x2, and the b is the 3, 2. Okay. And in order to do this, what we're going to do is we're going to do it figure x1 and x2 like that. And solve it like 8. Theorem 8. So A is 3s 5 and 12 and 5s. So then the determinant of 8, 3s 12 and 5s is equal 15s squared minus 60. So this is 15 times s squared minus 4. And then the A1B is going to be 3, 2, 5, and 5s. So the determinant of that is going to equal 15s minus 10. And then A2B is, that's 3s 12 and 3, 2. So the determinant of 3s 12 3, 2 is 6s minus 36. So then x1 equals, that theorem says Oh, it's not theorem 8. Oh, it's theorem 7. And that's the determinant of A1B over the determinant of A, and A1B is the 15S minus 10 over 15 times S squared minus 4. And then X2 is the determinant of A2B over determinant of X, determinant of A. And that's 6S minus 36 over 15 S squared minus 4. Now, these two things, this is what X1 and X2 look like. And the parameter, the S squared minus 4, cannot equal 0. And this factors into, well, by extracting square roots, we can say S cannot equal plus or minus 2. So the parameter cannot be plus or minus 2, and this is what the variables X1 and X2 are. And that's what they're asking us to. It says, determine the values of the parameter for which the system has a unique solution and describe the solution. So these are the descriptions of the solution, and the parameter can be any value except plus or minus 2. That makes sense. Okay, I'll do another one. I'll do 10 on that same. It's the same thing. All we have is we have S X1 minus 2X2 equals 1. This is an S. I hate S's as variables. 4S. Because they end up invariably, I confuse them with 5s. X1 plus 4S X2. So if we put it in the AX equals B format, we have S 4S, a minus 2, and 4S. And then X. Then B is 1, 2, 3. So if we do the, I'm going to write the determinant of A just with the bars rather than do determinant of A. So 5, 4S minus 2 and 4S. So that's equal to 20S minus 8S. Right? And that is 4S times 5S minus 2. and then the A1B. And we're going to do determinant of that. So A1B, it's going to be the determinant. And in place of in place of the first column, that's what this says, we put 1, 2, then we go minus 2, 4s. We're doing the determinant of that. And that's 4s minus 4. So that's 4 times s minus 1. And then the determinant A2b, that's equal to the determinant of s 4s. Then put the 1, 2 in place of second column. So this is 2s minus 4s. So let's factor out 2s times, well, it's just a minus 2s, right? Because if we got 2s and we subtract 4s, we get a negative 2s. So then x1 equals the determinant of A1b over the determinant of A. And A1b is at 4 times s minus 1. And determinant of A is 4s 5s minus 2. That's x1. And x2 is, oops, better put it up. X2 is the determinant A2b over the determinant of A. A2b is a negative 2s. And determinant of A is 4s 5s minus 2. So this is what x1 and x2 looks like in the parameter s. 4s cannot equal 0, so s cannot equal 0, and 5s minus 2 cannot equal 0, so s cannot equal 2/5. So this is the restraint on the parameter, and this is what x1 and x2 look like. Well, the next group of problems says compute the adjunct of the given matrix and use theorem 8 to give the inverse. And theorem 8 says what we got to do. Huh?
I have a question. We're doing it right?
Did I do it wrong? Oh. Okay, so this one, so what did I do?
So we're the determinant of A.
Yeah. Is it
first row, first column is supposed to be S5.
Oh, this is supposed to be an S right here?
Yeah.
So then that would be 4s squared? Okay, I told you. I hate them. S is 4s squared. And then the minus 8s is right. Is that right? Or is that plus 8s? That's a plus 8s, isn't it? It's a minus 2 times, so that's plus, isn't it? Okay, so I was wrong all over the place. Okay, so then this is a 4s out, right? Times s plus 2. 4s over s plus 2. Thank you. So this is 4s over s plus 2. 4s over s plus 2. So now the 4s cannot equal 0. So s cannot equal 0. And s plus 2 cannot equal 0. So s cannot equal minus 2. So that's the restrictions on our parameter. Thanks. Okay. The 8, notice on theorem 8 that the A inverse is 1 over the determinant of A times adjunct of A. So we're going to look at 12. And there they say calculate the inverse of that matrix. We get a matrix. 1 minus 2, 0. 1, 2, and 1, and 3, 1, and 1. Let's work on that determinant. So if I take that, if I can get it a column, so I'm trying to do a column, I mean the diagonal, so I get a diagonal matrix. So then I'd go 1, 1, 3, and then I'd 2 times the first row and add it to the second. So I would go 0, 4, and 4, 7. Is that right? 0, 1, 1. If I took a fourth of the second row and subtracted it from the third row. 1, 1, 3, 0, 4, 7, 0, 0. So this would be 1/4. 7, it's 1 minus 7/4. That's 4/4 minus, that's 3/4. Is that right? Now, my determinant should be the determinant of that matrix. I'll call it A. Should be the diagonal, right? 1 times 4 times a minus 3/4. Is that right? So it should be a -3. Is that right? But you get it? Yeah. Is that right? So this should be my determinant of my matrix. And now I get to get cofactors. Cofactors of the first row, first column. That's going to be 2, 1, 1, 2. It's the determinant of that. So that's 4 minus 1, which is 3. So there's that one. And then C, first row, second column. Okay, so then that's a -1, 1 plus 2, and it's 1 times the determinant of -2, 1, 0, 1. Make sure I do this right. So that's a -1, negative, and a -2, right? Okay, tell me. I'm doing this one, right? 2, 1, oh, 1, 1. Okay. So that's 2 minus. So then that's a 1. Okay. Now this one's right, isn't it? So this is a +2. Dang it. Oh, taking up too much room. C1, 3. Minus 1, 1 plus 3. And that's going to be 3 times -2, 2, 0, 1. That's 3 minus 2. Is that right? -6. Is that correct? Okay. So C, second row, first column, is a -1, 2 plus 1, and then that's a -2. And then crossing that out, that's a 1, 3, 1, 1, right? Which is equal to a -2 times 1 minus 3. That's a -2 times a -2, which is a 4, isn't it? And a C, 2, 2, -1. Oh, I think I did that because this one here this negative 1 is 2 plus 1 is 3. So then this sign is a negative, isn't it? That should be a negative 4, shouldn't it? This is 2 plus 2. Second row, second column. So that's 2. And then it's a negative 2, 1, 0, 1. So that's 2. That's a negative 2, right? So that's equal to a negative 4. Phi of 2, 3. Negative 1, 2 plus 3. So that's going to be a negative. And that's a 1. And then the cofactor is 1, 1, 0, 1. So it's got to be that's a negative 1, isn't it? Man. See, third row, first column, negative 1, 3, plus 1. So that's a positive. Well, that's a 0. So that's 0, right? Because it's 0 is 0. So this is 0. All right? Third row, first column is right here. So it's 0 times its. Okay. So C, third row, second column. Negative 1, 3 plus 2. So that's going to make that negative. And that's a 1. Determinant of its cofactor. 1, 3, minus 2, 1. So it's a negative of 1 minus 6. So that's a plus 5. Isn't that right? Am I good? It's a 1, 3, it's a minus 2 right here. So this is a plus. It's a negative. So that's a negative 7. So then C of 3, 3. That's going to be a plus. That negative is going to be a plus. So it's going to be whatever. It's 1 times its cofactor. And it's a 1, 1, minus 2, 1, 1, minus 2, 2. Which is 2 plus 2. 4, right? Now, when we do the adjunct, of A, what we do is we interchange the rows and columns. I wrote a cross, and the cross goes down. Understand? So it goes, this one goes there, that 2 goes here. Rather than being first row, second column, it's 2, 1. It's second row, first column. And then that's -6. You interchange the rows and the columns. And this is going to be a -4, -4, and a -1. And this is going to be a 0, -7, and 4. We said the determinant, now that theorem, it says the inverse, A inverse equals 1 over the determinant of A times the ADJ. So, and the determinant was -3. So it's 1 over -3. 1, 2, -6, -4, -4, and -1, 0, -7, and 4. So that's -1/3, -2/3, 2, 4/3, 4/3, 1/3, 0, 7/3, and a -4/3. That's what A inverse is. Supposedly. We did it right. Okay. Want to try another one of those, or is that just too much fun? Yeah. Is that enough of those? Do you understand how to do it? Okay. Okay. 18 says suppose that all entries in A are integers and the derivative of A equals 1. Explain why all entries in A inverse are integers. Well, the ADJ of A involves only products and sums. Hence what? Hence all entries in ADJ must be integers, right? Because if you take product of integers, you get integers. Sums and differences of integers is integer. So the adjunct has to be integers. And the determinant of A equals 1, and therefore 1 over the determinant of A, ADJ of A must be all integers. So that's why the A inverse is all integers. The next group says, find the area of a parallelogram whose vectors are listed. And theorem 9 says, if you have a 2 by 2 matrix, the area of the parallelogram is the determinant of A. And what you have to do determinant of the columns of A. So you can take any two columns, as long as one of the vectors is the 0, 0 vector. So like 20. You have 0, 0, minus 2, 4, 4, minus 5, and 2 minus 1. Now, one of those vectors is 0, 0. So if you take the determinant of any two of those, minus 2, 4, 4 minus 5. That's just so that's going to be 10 minus 16 minus, I have them written down right, 4 minus 5. Comes out a minus 6. So it's the absolute value of the determinant. It's the absolute value of the determinant. So it's the absolute value of that determinant, which equals 6. Makes no sense to have a minus 6. Now, this is the interesting thing, is it does not make it, as long as one of those is 0, 0. If you take any pair of those vectors, like minus 2, 4, and 2 minus 1. That's the absolute value of 2 minus 8, which is the absolute value of minus 6, which is 6. If you take the absolute value of the determinant, so I did the first one and the second, the first one and the third. I do the second and the third. Minus 4 plus 10. Don't make any difference which vector you take. Any two of the vectors, you do the absolute value of the determinant, you'll get the area. So you don't have to worry about which pair you use. The thing you have to do, it's like 22, is one of those vectors that's got to be 0, 0. Minus 2. Minus 3 and 1. And 2 and 1. No. None of those vectors is 0, 0. So if we simply take the first vector and add 0, 2 to that vector, so we get 0, 0, and then add 0, 2 to each one of those vectors. Now we can take the absolute value of the determinant of any two of those. 5, 0, minus 3, and 3 is equal to the absolute value 15, which is 15. Take the absolute value of the determinant of 5, 0, and 2, 3. We get absolute value 15, which is 15, or we take the determinant of minus 3, 3, and 2, 3. The value of a minus 9 plus, no, minus 6. Which is the absolute value of minus 15, which is 15. Doesn't make any difference which pair of vectors we use. We get the area. But we have to have one of the vectors has to be 0, 0 in order to do it. Otherwise you're going to have to subtract the difference and get, the length of the vector, and I mean that's just total confusing. Then 24 says find the volume of the parallel pipe head, one vector at the origin and the vertices up there. So 24, And once again, you notice that it's one vector is the origin, and then the other vectors are 1, 3, 0, minus 2, 0, 2, and the last one is minus 1, 3, minus 1. Now this is going to be then the determinant, the absolute value, the determinant of the three vectors. 1, 3, 0, minus 2, 0, 2, minus 1, 3. Okay. Absolute value. Now we can either expand along a row or column, or we can take this 1 minus 2 minus 1, 3, and get it so we get a column of diagonal, get it a rectangular vector matrix. 1 minus 2 minus 1, take 3 times negative 3, add it to 0, 6, 6, is that right? 0, 2 minus 1, and then we do 1. And I'm going to take a negative 1/3 times the second and add it to the third. 6, 6, 0, that would be 0. Negative 1/3 is 2. That would be a minus 3, wouldn't it? And then this is going to be, and then it's got to be the absolute value of this thing, which is the absolute value of 1 times 6 times minus 3. Which is a minus 18, which is 18. So the volume is 18, if I did it right. Does it look right? I think it is. Okay. I'll do one more problem. 28. And it says repeat 27 with B1 is that, B2, and A is that. 27 says let S be a parallelogram determined by the vectors B1, B2, and A. Compute the area of the image of S under the mapping. So this is theorem 10. And notice that the area of the mapping T of S is equal to the absolute value of the determinant of A times the area of S. So, first of all, the area of S equals the absolute value of the determinant of B1, B2. Which is equal to the absolute value of the determinant of 4 minus 7 and 0, 1. Absolute value of 4, which is 4. That's the area of S. And then the absolute value of the determinant of A is equal to the absolute value and the determinant of 5, 2, 1, 1, which equals the absolute value of 5 minus 2, which is equal to the absolute value of 3. And then if I substitute the area of the transformation S equals the absolute value of the determinant of A times the area of S. And the absolute value of the determinant of A was this thing, 3. The area of A is 4, so this is 12. So that's the area of the transformation. And